This time we're going to be covering triangle congruency. Last time, if you guys remember, we did triangle similarity. Now we're doing triangle congruency. So hopefully you can make the differences and you can see the similarities between all of them. So basically, that's the concept for this video. I'll explain more coming up. And guys, here's triangle congruency. So basically, triangle congruency, and I'm just going to start with identifying what congruency means. So similarity, I said, is basically there are similarities, meaning there are things that are the same. There are things that are the same with both of the figures. Now we're looking at triangle congruency, which basically means the figures are the exact same everywhere, ranging from the angle measures to the side length measures. So basically there are 5 different types of congruencies. So I'm just going to talk about them all right now. So I'm going to list them out for you, and basically there is some similar ones, just like SSS. And I'll tell you about why we do the equal and what's that all about. But basically, SSS is one of them. SAS is one of them. ASA is one of them. AAS is one of them. And we have HL. Now we have some similar ones in the case that we see SSS and SAS come back from triangle similarity. So basically SSS, and I'm going to explain why we do the equal sign with the similarity sign. So basically if they're congruent figures, of course they're similar, and they're in a ratio of 1 to 1, which basically gets the congruency. And now the equal sign, as you know, depicts that they're the exact same. So, of course, like, if let's say like anything, like 2 equals 2, then of course you see this equal sign, well of course 2 equals 2, you use that equal sign. So that's why we're using that. And you have to make sure to include that afterwards, because it's going to be very important. You can't just put SSS, because it might be similarity or it might be congruency, who knows. You have to include exactly that. So basically now I'm just going to describe each one in just a little bit of detail, and we're going to go into proving why some figures are what they are. And to be honest, this is going to be very helpful. The second part of this video, you might want to keep like rewinding and taking notes on it, and I'm going to tell you why. Because the final part of this video is going to discuss 2 column proofs, which you are going to need. Like, trust me, you're going to want to know this. So, yeah, basically we're just going to go into it. So, SSS congruency. Now we're looking at SSS congruency, and basically that means all the side lengths are the exact same, and they have to be in correspondence though. Okay, and of course SSS congruency, boom, you have it. And if 3 sides are all congruent, that means the figure is congruent, or the 2 figures are congruent. SAS, as we saw from last time, this can be used for similarity or congruency. It just needs to be in a ratio of 1 to 1, and the angle between the 2 sides have to be congruent. ASA, we're looking at a new one here actually. ASA is going to be angle, side angle, where the side is going to be between the 2 angles. And same thing with this one. This is also going to prove congruency. And then AAS, basically another variation of ASA, and you can prove it either way, to be honest. But ASA and AAS are 2 forms that you're definitely going to want to remember, especially in some examples I will show you later. HL is only going to be used basically when there's a right triangle and you're trying to prove congruency. Basically, you need to know the hypotenuse of the triangle, and you're going to want to know a side length. Because if, let's say, for example, you have a 3, 4, 5 Pythagorean triangle. So there, let's say you know that, of course, 5 is going to be the hypotenuse, and you have a side length 3. And then you have another figure that also has the side length 3 given, and the side length 5. Then you know it's congruent by HL because you know the other figure is going to be 4, which technically classifies as SSS congruency. But in two-column proofs, we don't really need to take that extra step, because technically knowing these two will automatically guarantee us into putting SSS as the next step. But since HL is a congruency theorem, we're just going to be using that over SSS. Now that basically you know the 5 patterns or congruency theorems that you are going to see often used, we're just going to go into some quick examples of some of the ones I found difficult personally when I was covering congruency, and hopefully we can make it much easier for you. Okay guys, what is going on? And we're back with another, well actually our first example here, and in triangle congruency, this is a quite hard one to start out with, but I want to engage you guys right off the bat. So we're just going to go right into this one and see what we're going to get out of this, and which congruency theorem it is going to be, if it is any. So basically, this is something you're going to see quite often, maybe not as much as the other figures, but you are going to see this sometimes. Definitely you, so you definitely want to know how to approach this kind of problem and solve it. So this might take me a bit of time to just get registered, but I definitely will solve the problem in the end, and I will show 2 ways that you will be able to solve it. So first of all, every time you start a 2-column proof, you just want to do this, and do this, and this is going to be your statement and your reason. So statement is basically where you're declaring congruency theorems are that one triangle is congruent to another triangle, this angle is congruent to this angle, this side is congruent to this side. Like, that's basically what you're doing. So basically what we have here is that DE, okay, they'll give you the givens usually, but basically what it's called is a given, which is the given information. They'll write it down for you, usually, but I'm just going to write it down for now. So if you look, we have side DE is parallel to side JK. And what you're going to do is simply write given, because that's given to you. Okay? Now the next thing is you see G right here. G is midpoint of E. You can minimize this, but I'm just writing the whole thing out so you can see what it is. G is midpoint of, not E. So G is midpoint of DK. Okay, so that means G is a midpoint of this basically long side. And also, because that is a given information, you're gonna write the same thing. And don't combine these two and say in the same statement. You want to keep it separate. Usually, I don't know. Depends. But usually they want it like that. Next is what you can start with proving anything, but it cannot result in more steps to prove something, because then it will it's just unnecessary to prove more than what is needed, and this is definitely an example where we're going to show that. So basically, these two are parallel lines. If you know anything about parallel lines, this is technically the transversal. Transversal cuts the parallel lines and creates lots of angles. Here you have the alternate interior. alternate interior angles. Alternate, and basically you just keep those two are alternate interior, those two are alternate interior, these are vertical angles. There's so much you can prove, but only some of this information is needed. So what we're going to do off the bat is we're going to prove, because vertical angles are always congruent, we're going to prove that angle DGE is congruent to angle JGK. So, DGE, JGK, which basically means these two are congruent. Okay, so now we know those two are congruent. That is going to help us later on. This is one of them you are going to have. Well, you don't necessarily have to prove this one, but it's recommended you prove this because it is one of the easiest ones to prove. Next, you're going to have to prove that one of these angles are congruent. I'm going to tell you why you don't need to prove both. Congruency. 3 sides, 3 angles do not mean the figure is congruent. 3 congruent angles does not mean it is congruent, which means you don't need all 3 angles, you simply need 2. So here in this figure, I'm just going to prove, we'll go ahead and prove that angle D and angle K are equal. So angle D and angle K, you have those two, and they're congruent. And, here we forgot to write the reason. The reason is very important, don't forget. But basically, I'm just going to do vertical angles for that. And these are alternate interior angles. Because technically, when parallel lines are cut by a transversal, they will create these alternate interior angles. Now we know that these two are the same. And these two figures correspond. So now we have angle. We don't have a side length, but that's where the second part of information comes in. The first part was used to figure out, the angles and their congruency. Now, the second part of the figure is, second given information is going to prove that 2 sides are congruent. And it might seem, how is a midpoint of a side supposed to prove that 2 figures are congruent? And sometimes it's going to be like that. Basically, if G is a midpoint of B and K, we know that BG is going to be equal to GK because midpoint. Technically, a midpoint bisects the side, which means bisects means cuts it in half, which means DG and GK are going to be congruent. And just for the sake of time, we're just going to shorten that down. Basically what I said, G is the midpoint, cuts this side in half, and that means this right here and this is going to be equal. So DG and GK are going to be equal, which makes our last piece of information, just for the sake of time, I'm going to write that. Basically what you would say is, because DG is equal to GK because midpoint G bisects side DK. And that's what you're going to write. Then, by congruency, you can say ASA. By ASA congruency, DEG is congruent to KGJ by ASA congruency. And there you have it, guys. That's how you prove triangle congruency. Make sure to tune in for our next video. But that's going to be it. Thanks, everyone, for watching. More examples like this will be posted on our website if you want to see. That's going to be it. Thank you guys for watching, and I'll see you later.